Let us continue the problem. So first, the first equation I can write is that Ex is equal to Tx equals to 150 sine theta. The second equation I can write is that Ey, so now sum of y equals to 0, will give me, I have minus 20 times 4, so minus 80, okay, plus Ey minus the plus Ty, and Ty is negative, it's minus 150 cosine theta equals to 0. This equation will give me the value of Ey. And finally, to get the couple ME, the equation is sum of moments. You can select any point here, but the easiest one will be E to cancel out the moment of Ex and Ey. Okay. Also, if you want, you can take D. It's good to take D. Look, because if you take D, the moment of the 150 kilonewton force is cancelled, and the moment of Ey is cancelled. Okay, so D is the best choice because you will only have the moment of Ex and the other forces. Okay, plus the couple of force. So I will choose to do sum of moment about D. Sum of moment about D equals to 0. Let us select the counterclockwise as positive. So we have plus ME. Now for Ex, is it producing a positive moment or negative moment about D? Look, Ex is doing a clockwise moment, so it's negative. And the distance from D to E, I should multiply by this distance, which is 6. So I will do minus Ex times 6. Now, for the other forces, the 20 kilonewton forces, all are producing counterclockwise moments, okay, about this point. So the first force of 20 kilonewton, I should multiply it by this distance, which is 1.8. The second force, I multiply by 2 times 1.8. The third one, I multiply by 3 times 1.8. And for the final force, I multiply by 4 times 1.8. So in total, I have a plus 20 times 1.8 plus 20 times 3.6 plus 20 times 5.4 and finally plus 20 times 7.2 equals to 0. The only unknown in this equation is the moment about E. I get its value. Okay, so in this way I have calculated the 3 reactions at E. So let us see the solution. So first, as we did, sum of x, sum of y to get Ex, Ey. Now for sum of moments, I selected to do sum of moment about E instead of D. It's also feasible. Try to do it and you will see that you will get in both methods the same result. Okay. So if you do sum of moments about E, you will cancel the moment of Ex, Ey, and you have that the tension in the cable for Y component, it will not do a moment about E. You will only have the moment of dx, the tension in x. Okay. So if we choose to do sum of moment about E, for example, also considering that the counterclockwise is positive, I have first a plus ME. For the 20 kilonewton forces, it's the same moment about E or D because the distance is the same. And when you do the line of action of these forces, okay, so this is the line of action. If you do extension of these lines, the distance from D to this line or from E to this line is the same. So you can see that I have the same expressions, 20 times 7.2, 20 times 5.4, 20 times 3.6, and 20 times 1.8. Now just the different term will be the moment of dx about E. And the moment of dx about E is here clockwise. It's equal to dx times 6. Okay. And as you know already, dx is calculated as 150 sine theta. And dx and dx are opposite. So we will obtain the same equation obtained before. Okay. So in this equation will give us the value of m. Any question on this problem? Okay. Now, another problem, I will just here, we can introduce this problem. The 10-ton moving crane shown below has a mass center at C. It carries a maximum load of 18 tons. Find the smallest weight of counterweight C and also the largest distance D so that the crane doesn't tip clockwise when the maximum load is lifted. So this structure, you see it a lot, okay? It is widely used in constructions and its purpose is to lift high weights. Now, when designing the structure, we should pay attention for two things. So first, as you can see, here the center of the structure is little bit far from the support. So you have here RA and RB, and the weight is from this side. So imagine that you don't have when you are not having a load here. If I have zero load, I have a risk of tipping over. Tipping over about which point? يعني هتجرب توقع الستراكشر. Yes. إذا ما في load هون, okay, وعندي weight here, the weight will tend to rotate the structure like this. It will try to rotate it in clockwise direction. يعني I will have tipping over this point. يعني ببرم around B. مظبوط؟ يعني I will lose contact with A due to the weight. To avoid this, to avoid losing contact with A and tipping over B, I will put a counterweight. Okay? So when I design the counterweight, I should design it in a way to prevent tipping over when I have zero load. And the other purpose of it is the second extreme case. The second extreme case, when I have a maximum load. When I have a maximum load here, just concerning the idea of the counterweight, if you don't have any, in general, the weight of the structure will be smaller than the maximum load you will have. Okay, so when you just if my structure already contains the counterweight and plus the weight, okay, but the counterweight in general is larger than the value of the weight. This is why if I have zero load here, if I don't have any load, and I have the counterweight and the weight, because the counterweight in general is high, okay, when I don't have any load, my the tipping over will be my structure will tend to rotate in the direction imposed by the counterweight, because the counterweight will be in general having a weight higher than even the weight of the structure, because the structure doesn't have a very high weight. You can see here you have a lot of voids in it. Okay, so in the absence of a load, the counterweight will be dominant over the weight, so it will try to rotate in this direction. So it will try to tip the structure over A. Okay, and we will lose contact with B. And in order to avoid this, we should pay attention to this design to minimize maybe this distance, because if we minimize it by proper design, we can reduce this moment about point B. Okay. On the other hand, when you have a full load from this side, due to the presence of the full load, you have a risk of tipping in the opposite direction. Okay, because of course the maximum load you can sustain will be higher than the counterweight, and in presence of this load, you will have a possibility to turn your structure like this. So you will have a possibility to lose contact with A and then rotate about B. Okay, so these two cases should be avoided. This is why when we do the design, we should try to find what is the value of the counterweight and what is the value of D in order to avoid these two extreme scenarios. I don't want to have, when I have zero load, I don't have to tip over in this direction. And when I have a maximum load, I don't want to tip over like this. Okay. Next time, try to do it. Try to think about this problem now, and we correct it next time. Okay.
Thank you, doctor.
Any questions?
Thank you.
Welcome.
Thank you, doctor.
Welcome. So we continue.
Thank you, doctor.
Bye.
Thank you, doctor.
Doctor,
Yeah.
I wanted to talk to you about the exam.
Yes, Yalla. I just let me stop recording.